Hello, welcome back to Pre-Algebra with Miss Betsy. Well, we're getting down to the end of the year. We're working in our last chapter today. We're going to be talking just a little bit about the concept of square roots. Now, it doesn't matter what textbook you're using, but if you happen to have the same one that I'm using in this video, it looks like this. It's Pre-Algebra for Christian Schools, published by Bob Jones University Press. It's the first edition. I'm in section 14.1 on page 483. So let me see if I can remember. Yes, here is our lame joke for today. Can you tell me what it is that happened when the dog went to the flea circus? Well, he stole the show. So this concept that we're going to be talking about today is not necessarily difficult, but it can be worded a little bit strange, and it can be a challenging concept to really grab hold of. I don't think you guys, my co-op class, I don't think you'll have much difficulty with this, but I'm going to teach it a little bit differently. I'm going to go through the one page of the book that we have, and I'll read a little bit, and then I'll tell you what we're talking about. But first, I want to remind you of what inverse operations are. Inverse operations are those things that undo one another. For example, if we start with a 2, and I'm going to multiply that times 3. So 2 times 3 is equal to 6. So what we've done here is we've begun with 2, we've multiplied by 3. And we ended up with a product of 6. Now what I have to do to this 6 so that I end up back with the original number that I have? Well, now I'm going to divide by 3. And if I say 6 divided by 3, then I end up with a result of 2. And I've come full circle. I began with 2 and I ended with 2. So you remember that inverse operations are operations that undo one another. If I start with a number and add 6, the inverse operation is to subtract 6, and there's no net change in what I have. Well, we're going to see that squares and square roots are the same thing, in that they are inverse operations. And I've said, let's learn to recognize perfect squares. A square, if you want to square a number, that does not mean that you take your 8 and you make your 8 look like you have 2 squares on top of one another. That would be rather lame, isn't it? That's not what it means when we square a number. But squaring a number looks like this. This says 8 squared. It has that exponent up there. And what that means is it says use this 8 as a factor 2 times. So 8 squared is equal to 8 times 8, which is equal to 64. 8 squared is equal to 64. And you can continue to learn the first 15 or 20 perfect squares. What do I mean by perfect squares? We're going to take our numbers. We're going to say 1 squared is equal to 1 times 1, which is 1. 2 squared is equal to 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 16. 5 squared, 25. And you see what I'm doing here. 6 squared, 7, 8, 9, 10 squared is 100, 15 squared is 225, 25 squared is 625. You know, just the first few numbers, if you can remember them, memorize them, it will make your life a little bit easier. These are what we call perfect squares. They come out to be a regular whole number. But if we took 3.5 times 3.5, it's not going to be a whole number. So now that you're reminded what it means to square a number, and to what perfect squares are, I want to introduce the concept of a square root. 2 squared is equal to 4. There's this symbol, it sort of looks like a long check mark. This is called a radical sign, or a radical symbol. And that's what we call we're taking the square root. Sometimes, a lot of times people will call this a square root symbol. And we'll see later next year why sometimes it's a square root symbol. The little number that they have up here tells you if it's a square root symbol or something else. But for now, all you need to know is when you see this thing that sort of looks like a long check mark, this is a radical symbol and it indicates that we're going to take the square root. And the square root of a number, to take the square root of a number, is the inverse operation to squaring a number. When we have the square root of a number, what that says is we're looking to find one of a number's 2 equal factors. If we were to factor 4, that's equal to 2 times 2, isn't it? We have a double factor underneath that radical sign. 2 times 2 is 4. So the square root of that number is 2. Another way of saying that is if you take 2 and you multiply it by itself, you get back that number. Okay, that's an introduction to it. Let's go ahead now and read through our section, see what we're talking about. And this may be very familiar to some of you. Others of you may not really have heard of this before. Recall that to square a number, you multiply the number by itself. Consider the square of the number 9 below. So we have 9 with the exponent. That's equal to 9 times 9, which has a value of 81. And you've heard me saying this is read 9 squared is equal to 9 times 9. 9 times 9 is equal to 81. Now it says the inverse operation of squaring a number is taking its square root. The square root of 81 is the number whose square is 81. The square root, let me write out what they're saying. The square root of 81 is the number that, if you take its square, you get 81. That's what that says, just in numbers. The square root of 81 is the number 9 because when you take 9 and you square it, you get 81. This is the multiplication fact. 9 times 9 is 81. 10 times 10 is 100. 6 times 6 is 36. So the square root of 36 would be the number 6 because when you take 6 and you square it, you end up with 36. So that's what they're talking about with this terminology in your book. Let's go ahead and continue. For every positive number has 2 square roots. One is positive and one is negative. Now you learned a long time ago that if you had 2 negative numbers and you multiplied them together, you always got a positive number, didn't you? If you had a negative times a positive, like a negative 2, let me go back to the negative 4. Negative times negative is always positive, isn't it? So negative 2 times negative 4 is a positive 8. But if you had one negative and one positive factor, you always ended up with a negative product. What we want to focus on here is negative 2 times negative 4 is equal to 8. So when you take the square root of a number, we're looking for two factors, right? So 9 times 9 is going to be equal to 81, isn't it? Square root of 81, 9 times 9 is equal to 81. But it's also true that negative 9 times a negative 9 is equal to a positive 81 as well. So your square root can be a positive 9, a positive or a negative. So it has two possible answers. If we say that the square root of 81 is equal to 9, this is what we call the positive square root. And they also call that, I don't know that they say that here, it's what we call the principal square root, but just for now, just know it's positive square root. And if we say that the square root of 81 is negative 9, what do you think they're going to say there? Exactly, that's the negative square root. And there's a lot of terminology and math speak in this section, but I think if you just focus in on what they're talking about, it won't be difficult for you at all. Now this says, find the square root of 25. This is our example. Find the square root of 25. This says, square root of 25. What number multiplied by itself is going to give you 25? 5 times 5 is 25. So this is the positive square root of 5. If they don't tell you they specifically want the negative square root, you can just indicate the positive square root. Now, let's look at this. What if they have this thing right here? You can read this as the opposite of, or the negative. This is the opposite of the square root of 49. What's the square root of 49? It's 7. Negative 7. Or this is the negative square root of 49, which is going to be a negative 7. And for now, just go with it. If it doesn't tell you, doesn't put a negative sign in front of it, I want you to give us the positive square root. If they put a negative sign in front of this square root symbol, go ahead and give us the negative 7. As you move on into Algebra 1, they're going to talk more about positive and negative square roots, but they're introducing this concept to you here. Now, let's look at this. Here's some more math speak. It said if the square root of x is an integer, it's a perfect square. If it's an integer, it's what we call a perfect square. What that means is if you have a number underneath the radical sign that you can actually say, oh, I know that 8 times 8 is 64. This is what they call a perfect square. And it's a rational number. Now, let's say that you have the square root of 63. Okay? This means that x, square root of x is an integer. All that means is there's a number underneath the radical sign, and it has to be an integer. If the result is a whole number like this, it's called a perfect square. Now, can you think of a number that if you multiply it by itself, you're going to get 63? No, you're not going to get 63. So you can't put an answer here. This is what they call an irrational number. More vocabulary. Do not get yourself all tied up in knots about this vocabulary. This is just an introduction to stuff that you're going to be covering next year. Okay. Now, this is a perfect square. This is a square root. It's a perfect square. You can come up with an idea of where this square root of 63 fits in between two numbers. Let me go ahead and erase this. Let's look at our text again. Page 483. When x is not a perfect square, you can estimate the square root of x by finding the two consecutive integers between which the square root lies. Now, that almost makes my eyes glaze over. Okay? What are we talking about? Example 2. Between what two consecutive integers does the square root of 32 lie? Can you think of a number right now that multiplied by itself is 32? Well, no, you can't, because 32 can be written as 1 times 32, can be 2 times 16, it can be, oh, what else is it? 4 times 8 is 32. But there's not some number in here that when you multiply it by itself, you end up with 32, is there? This is why I said it's a good thing if you can memorize your square roots. I mean your perfect squares. What is 4 squared? 4 times 4 is 16. 5 squared is 25. And 6 squared is 36. Aha! Where does 32 fit? Is it between 16 and 25? No. 32 fits in here in between 25 and 36. So this is how you're going to write your answer. And I'm going to put in an extra step that they don't show, because I think it might help you understand a little better what's going on. If we put square root of 25 is less than the square root of 32 is less than the square root of 36. Does that make sense to you? 2 is less than 3. 3 is less than 4. It doesn't matter if you say 2 times 3, 3 times 3, 4 times 3. As long as you're applying the same operation to a number, they still stay in the same order, right? 25 is less than 32. 32 is less than 36. Let's go back to here. Everybody agrees with that, right? What if I multiplied this by 2? 25 times 2 is 50. 32 times 2 is 64. And 36 times 2 is 72. The numbers are different, but the relationship between them is still correct. What if I wanted to subtract 5 from each one? 25 minus 5 is 20. 32 minus 5 is what? 28. 36 minus 5 is 31. The numbers are different, but the relationship between them remains the same. So we can go in and say the square root of 25 is less than the square root of 32, which is also less than the square root of 36. Now remember, all that square root is we're looking for a number that when you multiply it by itself or you use it as a factor twice, it's a whole number. What times what is 25? Well, 5 times 5 is 25. So the square root of 25 is 5. We don't have a whole number that we can use for the square root of 32. But we do know that 6 times 6 is 36. So this is what your answer is going to be. Our original question says, between what two consecutive integers does 32 lie? The square root of 32 lies. So the square root of 32 is between 5 and 6. Okay? Straightforward? Now, you've learned about grouping symbols. You know that when you have something in parentheses, you have to do that first. Perform that operation first. If I have 3 times 2 plus 6, we're ignoring the fact they have something called the distributive property, but you would add within these parentheses first. 3 times 8 would be 24. Well, that square root symbol is a grouping symbol as well. So if you have something like the square root of 16 plus 9, every bit of that is underneath the radical symbol. Okay, so you're going to add it first. And I'm doing this in the reverse order, but it'll be all right. Radical symbols are grouping symbols. So before you can take the square root, this is not the square root, this is not 4 plus 3. You have to add all of this together first. So this becomes the square root of 25, which is 5, because 5 times 5 is equal to 25. Now, if this had been different, if this had been the square root of 16 plus the square root of 9, we have a totally different problem. Here they're saying what number multiplied by itself is 16. 4 times 4 is 16, so this becomes 4 plus 3, because 3 times 3 is 9. We have a result of 7. I want you to study this just for a moment. It is very important that you realize that the radical symbol here, the square root sign, is like parentheses. If you have operations together underneath that, you have to perform that first. These are not the same problem. Okay? So now let's go ahead and do just a couple of quick examples here. And I think by now you should have a really good idea what's going on. Find each square root. This is problem number 6. The negative square root of 16, or the negative square root of 16, what number multiplied by itself gives you 16? It's 4. So the answer is simply a negative 4. What if they're asking, this is problem number 7, they're asking for the square root of 144. Now they told you the square root can be positive or negative, but they don't want you to show the negative square root here. They just want you to say what positive number multiplied by itself gives us 144. 12 times 12 is 144. That's all there is involved in this. If you will memorize your perfect squares, 1 through 20, and 25, if you haven't already memorized those, if you'll go ahead and memorize them now, you'll have a leg up on next year's work, and it'll be simple for you to do this homework. Just write them out. You will know 1 through 10 for sure. I told you earlier that 15 squared was 225. 25 squared is 625. You probably know that 20 squared is 400. You already know most of them, but invest a little bit of time in memorizing your perfect squares, and then finding square roots is very, very easy. Let me do one more where we're estimating the value. This says, between what 2 consecutive integers does each square root lie? Okay. Question number, let me see, question number 14. Square root of 107. There's no number that when you multiply it by itself you get 107. However, 10 times 10 is 100. So 10 squared, let me see how I want to do this. 10 squared is 100. So you have to figure out what 11 squared is. 11 squared is 121. 107 is going to fit exactly in the middle of this. So what's the square root of 100? The square root of 100 is 10. Square root of 100 is less than the square root of 107. And that is less than the square root of 121, which is 11. This is the only thing they're showing you. If it helps you to go ahead and write in that extra bit that I showed you earlier, square root of 100 is less than the square root of 107. That's also less than the square root of 121. That might help you to understand what they're talking about a little bit better, but this is what they want you to show. Between what two integers is the square root of 107? Now, this says evaluate each expression. Let me go ahead and show you number 21. This is where we're making sure that we use the radical symbol as a grouping symbol. This is number 21. And we have square root of 29 plus 7 minus the square root of 25. I tried to write 24 and that doesn't work. If you have operations that occur underneath that radical symbol, you have to do those first. So we now have the square root of 36 minus the square root of 25. But we don't combine these underneath and say that this somehow becomes the square root of 11. Because we can find that 36 is a perfect square. 6 times 6 is 36. So the square root of 36 is 6, minus the square root of 25 is 5. So that's what the solution is to problem 21. Go ahead and work on those. If you have any difficulty, I really don't think you will, but if you have any difficulty, send me a text and I'll be happy to help you out. I'll see you on Friday.